changing the tension by putting different weights on it, correct? Mm-hmm. So that means we would write the square root of tension over mass per unit length equals F lambda. Agreed? Mm-hmm. So T over mu is equal to F squared lambda squared. Mm-hmm. And I think I'm going to move this down, 22.8. All right, now, I am controlling the tension, correct? If I'm controlling the tension, that means it should be the x-axis. Yes, no? Mm-hmm.
Yes.
And we are reading the frequency, yes?
Yes.
Yes.
So that means that I want to solve this for
frequency.
Frequency. Probably frequency squared, yes? I love the fact that you all are smarter than I am. All right, so frequency squared equals, so it would be tension's being pulled out, right? So then frequency squared, I divided both sides by lambda squared, correct? So 1 over mu lambda squared?
Yes.
That's a lie.
What?
Oh.
No, it's good. That's good. All right. So when we get our slope, what we should be able to then do is verify 8.02 times 10 to the negative fifth.
Oh.
Yes? So this is the true answer. And the slope of our line will give us an experimental answer. Yes? Okay. And then we can see how close we come experimentally to true.
So we want to experimentally calculate the linear mass density?
The linear mass density of a string. String. It's actually a monofilament fishing line.
And is this part 2?
This is part 2.
So how do we determine the wavelength? Because
the wavelength never changes because of the fact that it only vibrates from here to here. So this is going to be a loop always.
but only one, like what would be?
Only one loop. Only one loop. Anything else you see up here will be what's called overtones, and we don't want those. We want the bottommost value.
Okay.
Okay.
The pulse, so
Right.
it would be one.
Right.
Gotcha.
If we have an overtone, then we can see it, but we don't record
So
the
if we were
overtone.
going, flipping it like this, then there'd be more.
Yes.
Gotcha.
Yes. So you might have 3 or 4 resonances in it, like a
Okay.
guitar string, but we want the lowest one.
Gotcha.
All right. Well, there's a title on the top of the paper, but it's again dealing with the speed of sound. Okay?
So
It's just doing the speed of sound with a slightly different approach. Okay? Well, or the speed of a wave. You call it the speed of a wave, not the speed of sound.
Wave speed in string with tension.
Good. Perfect. Perfect. All right? Now, I don't think I can make this any bigger for you. See, if I make this bigger, it isn't bigger. Are you following me?
Yep.
So that means that you all are going to have to get up close and personal and read it off the scale. So you're going to have to come, and when I do it, read it off the scale. And all right, so let's see how little tension I can put on it and you can read it. What'd you say, 22.8 was our length?
Yeah, centimeters, so 0.28.
Okay. So now where is the blue ruler you used?
Oh, I have it, sorry.
Okay, that's okay. I just want to measure close to the center. All right. So close to the center would be this line right here.
Can I just cut out this?
Yes, you may.
Awesome. That's a really good idea. Okay, so that's about. ¿Dónde está? La ventana. It's done. It's actually technically done.
Okay.
Sí. Sí, lo siento.
That's low. Oh, wow.
Let me turn the sidelight on. Although you may not even want the sidelights on. All right.
I'm sure this focused right.
That may be too much to not be able to read it. Okay,
We're good.
so, if this one vibrates, it's 150 grams. All right,
So we turn that into newtons per tension.
there we go. Now, do you understand that someone's gotta have to get up close and personal?
I will. Or Alan, Alan, you do it.
Okay, I got it.
It's all you, bro.
All right, so you're gonna have to get your scale, and you're gonna have to get the average, because I can only do this so fast. Okay,
What am I-
you're reading the low number,
The low,
where the blue is, at the very bottom.
like
The dots,
here?
yes.
Oh, the dots.
We're only having one string though, right?
Oh.
And you wanna know, actually, I can do the
How am I
following.
defining, like, this is the 1K thing?
Okay, just a minute. The 1K means 1,000.
Oh.
So
Okay.
that means that each of those little dents is a 100,
How do I
right?
Okay.
that?
And if you go up, the next one is 2K, 3K, 4K, 5K?
Yep.
Yes? All right, so now, here we go.
So am I looking at this one?
Yes, at the very bottom.
Oh, at the
That
very-
line of dots at the very bottom.
But it looks like it's, this is very hard to read.
I know, that's why I said you had to get up close and personal.
How am I supposed to make an estimate off of the very bottom?
Good luck, honey.
Would it just taking like wild, like 20? Like, I don't, like, it
Come-
doesn't
Somebody
look
come
like,
up and help him.
it doesn't look like it passes the first tick.
Yes, it
Where are my
does.
good glasses?
Wait, okay, wait, what are we talking?
You're talking about a line of dots that's gonna be right about here.
Oh.
Okay?
Those?
All right, so let's
Oh,
try
You
again.
said the dots at the very
Okay,
bottom.
my fault, my
Alright.
fault, okay. Do you see the line of dots
Yep,
every
there
time
it
you
is.
hear
So
something?
this is 1,000.
Okay, so
Then it's about
4.
1/4 of 1,000.
So
So
250?
250.
Okay. All right, now the next one is gonna be
You
250.
got it on this next one?
Alright, I'll
Yeah,
try.
we're gonna do them all. All right,
The
so
first
this one is
150.
250. Since you have more tension, what do you think's gonna happen?
It's going to increase.
Frequency should get higher, right?
No, we're recording the tension in newtons, correct?
You want the tension in newtons in this chart, yes.
Okay.
Okay?
What is it? 250 of what? Oh, 250. So 250 for the first one.
I'd say that's like
Tension
Four.
was what?
100.
No, 4.9.
Okay, he's gonna go for 400. We'll find out in just a minute. All right, this is 350,
So,
okay?
Oh, 350?
so what are these
Wait, what was the
brighter?
first two?
So,
Background noise.
250.
no,
Oh, I had no idea what those are.
like the,
Wait.
I'm trying to
Wait.
think of a,
Our first one was 150, right?
Okay, wait a minute, let me see if I
No,
can make that
frequency,
better
first
for
one
you.
was 250 and then 400.
Now, it looks much better up here,
Miss Colwell,
sweetheart.
what were the first two hanging masses?
You wanna come see it up here?
Maybe? I'm just
Alan.
making sure we're putting
What?
it in
Oh.
right.
Come see it up here? See if it projects better up here, all right?
What have we
So,
done?
oh, yeah.
okay, now don't touch anything quite yet.
Sorry. Oh, there's 2 lines.
Okay, that means I'm not at the center. I did the bottom one,
So which
Okay.
line would we choose here?
the bottom one.
Oh, okay.
4,
It's about
Except
half.
we have to change, so if we don't change, I'm in trouble.
It's 500.
5, yeah, 5.
Okay, now that, Annie, we
Was
did
350.
150, 250, 350.
Okay, so
Okay.
that was 500 at 350.
We can go
250
back
was
in just a
400.
minute, once we do more, all right? So now, this one is 450, okay? And Alan, I do wanna try to get
What was
this
the-
one good resonance here.
Okay, so that'll be, make sure you're doing the 1.5, 2.5.
That's pretty good, actually.
I'll just make a little column myself.
It's a little bit higher.
Actually, wait.
Maybe 0.15, yeah. 250 grams is
Move the point over one.
I'm just writing it down. Okay, go ahead.
I go with about 5:30.
5:30. Your estimate's